This is the solution video for section 8.2, problems 12 through 15. All right, so it says sketch the graph the region bounded by x plus 2y equals 4, x equals 0, y equals 0, and then set up an integral for the volume of the solid generated when this region is revolved about the given line. All right, so we've got four different problems that are all associated with that region. All right, so let's start off. X plus 2y equals 4. All right, so this is a line, all right, but I'm going to solve it for y. So I'm going to subtract x, so 4 minus x, and then divide by 2. Right now, you could rewrite this as negative 1 half x plus 2, right, to make sure you know what that line looks like. Then you have x equals 0 and y equals 0, just the axes. All right, so negative 1 half x plus 2, right, so that'd be a line, slope of negative 1 half, y-intercept of 2, right? So this goes through 0, 2 there, and then this goes through, well, this would be when y is 0, right? So if y is 0, x is 4, right? So this is 4 comma 0, right? All right, and so then the x and y axis, right? So we're looking at this region. All right, so let's start off with problem number 12. All right, so 12 I'm going to do in this color. All right, so y equals negative 2. So y equals negative 2 is a horizontal line here. And so if we revolve around this horizontal line, we want to use a dx because that would be perpendicular, right? So we're going to set up, we're going to say pi times the integral of parentheses with respect to x, and then I've got big R squared minus little r squared. All right, so now number 12. All right, so the upper boundary is the axis of rotation, or sorry, is the line, right? So 4 minus x over 2, so 4 minus x over 2, and then minus the axis of rotation, which is y equals negative 2, right? And so that would be minus negative 2, or you could write it as plus 2. Then little r is the nearer boundary, which is the horizontal line y equals 0, minus the axis of rotation, so that'd be 0 minus negative 2, or just positive 2. And then we're going to integrate from left to right, so 0 to 4, right? Now, of course, you can simplify this, right? But I would not simplify further, right? So our simplified version would be pi times the integral from 0 to 4, right? And then we've got 4 over 2, which is just 2 plus 2, so that'd be 4. And so then I'd have negative x over 2 plus 4, or 4 minus x over 2 squared, and then minus 2 squared, which of course you could just write as 4. All right, and then all of that with respect to x. All right, so that is number 12. All right, so let's do number 13. All right, so 13, y equals 5. Now, y equals 5 is a horizontal line, which is above the axis here, right? Or above the region. All right. And once again, we're going to use a dx, right? So now pi times the integral, parentheses with respect to x, big R squared minus little r squared. All right, so big R. Now, big R, well, is found by taking the distance from the axis of rotation to the further boundary, which is the y-axis, right? And so we're going to take the axis of rotation, which is 5, minus the furthest boundary, which is 0. All right. Then, okay, on the little r is going to be the distance from the axis of rotation to the nearer boundary, which is the line. And so we're going to take 5 minus 4 minus x over 2, right? And then obviously we're going to square that. All right, and we're going to integrate from 0 to 4. All right, so now, can we do a little bit of simplification there? Of course, right? We could rewrite this as 5 minus 4 over 2, which is 2. So 5 minus 4 over 2, which would be 3, right? So I have integral from 0 to 4 of 5 squared minus 3, and then it would become plus x over 2 quantity squared, right? All right, so that's 13. All right, let's take a look at 14. All right, so 14. Now, x equals 7. So x equals 7 is a vertical line over here, right? And so now that means I want to switch to a horizontal rectangle. So we're going to use a dy. So now I have pi times the integral of parentheses with respect to y, big R squared minus little r squared. All right, so now with the dy, all right, big R. So the boundary of the region furthest from the axis of rotation is actually the y-axis, right? So we're going to take the axis of rotation, which is 7, minus the y-axis, which would be x equals 0, right? So 7 minus 0 squared. Then the axis of rotation minus the nearer boundary. But the nearer boundary we haven't written in that form. So we actually need to take that and solve for x. So if I get x equals 4 minus 2y, right now we're going to take the axis of rotation 7 minus the 4 minus 2y. Remember, it has to be an x equals form in order to use a dy. All right, and then we're going to integrate now. We're going to integrate from the lowest value to the highest value. So that would be from 0 to 2. All right, and then of course you can rewrite a little bit. So integral from 0 to 2 of 7 squared minus, and then here you would distribute that negative. So you have 7 minus 4, which is 3. So 3 plus 2y quantity squared with respect to y, right? So that would be our answer for number 14. All right. And then lastly, number 15. All right. So how about this color? All right. So x equals -4, which is a vertical line over here. So once again, we're going to use a dy. So integral, so pi times the integral, parentheses with respect to y, big R squared minus little r squared. All right. So now the boundary of the region furthest from the axis of rotation now is the line, right? So we're going to take the 4 minus 2y minus the -4. All right. So minus -4, that would be like plus. All right. And then the nearer boundary, which would be 0 minus -4, right? And so to simplify, we get pi times the integral 4 minus 2y plus 4, so 8 minus 2y squared, right? And then minus 4 squared with respect to y. All right, and then now we need to integrate from lowest to highest. So once again, 0 to 2, right? So 0 to 2. All right, and so that would be it for 12 through 15.